Welcome in the arena. My name's Allyson Klein. We are coming to you from the OCP Summit in San Jose, and I am so delighted because we are with Lisa Spelman, CEO of Cornelis Networks, and Zane Ball, CTO of OCP, for a fun and delightful conversation about everything around AI computing. Welcome to the program, guys.
Thank you.
Yeah, thanks for having us.
So, OCP Summit, leading the future of AI. When you think about leading versus following an AI infrastructure, what does this distinction mean to you?
Maybe I'll go first on this one. But in the world of AI, I feel like, I hate to say that, there almost is no follow. You have to be leading, you have to be foot forward, and you have to be solving not just today's pressing problem, but tomorrow's pressing problem. The hardest part I think that we're all facing is seeing that future in a world that moves so fast. I mean, anyone can think of 2 years ago what we were talking about, a year ago, 6 months ago, and that pace just keeps accelerating. So for those of us working on long-term projects, silicon innovation to support AI, it really is a big thinking challenge to stay on that front foot and be leading. I think the follow is hard.
From my perspective, it feels like up until now in the infrastructure world, AI has been kind of inflicted on everyone.
Yeah.
I was talking about the keynote yesterday that, we've run out of words, because for years people come to these conferences and talk about unprecedented, exponential, huge, and this is like 100 times bigger than any of those things. So it's sort of, you've been saying unprecedented, for years, but actually, no, it's really unprecedented. And it's like civilizational infrastructure building out, and it's the degree to which it's really hard to put a supercomputer on the ground every week. So, at some of these companies, and leading on AI means getting on top of this for once. Like, we really had, especially at the facility data center level, we really got to change our mindset that, no, we've got to think very differently about how this is done. And instead of, running around with our hair on fire, it's time to, it's time to get really proactive and lead on these things and do it collaboratively.
Yeah, I like what Zane said, but I think there's so much pressure when you're an operator in these roles. So this separating out the hair on fire, which has led to amazing advancements, even like I said, over the last 6 months in what we're able to do. And finding the time and the brain power to step back from that and think about it more systemically, it is a real challenge because the hair on fire doesn't stop. And so, you're trying to create space for that type of thinking inside of an incredibly constrained talent world as well. So it's a big civilization challenge.
I wanted to ask you this question because I know that you worked very closely at a previous company building foundational technology with the industry and delivering this broad proliferation of data center capability. When you look at this moment, what are we doing right? And what do we still need to work on in terms of showing up for this, moment in civilization, if you will?
The way I kind of think about it, like when we go through big technological changes, they're almost always built on top of the last one. Like, we didn't get automobiles, would have never been possible without railroads. But the ecosystem had to evolve very significantly to do that. But you wouldn't have had the ability to build roads or finance things had you not gone through one. And, you couldn't have done mobile had you not done PCs.
Yep.
Right.
And I don't think you could do AI if you hadn't built out cloud infrastructure before. But it's not to say that it's at all the same. Cloud infrastructure is really quite different than AI infrastructure. And so while we build on all the smart things we did in the past, we have to solve a bunch of new problems. But we wouldn't even be where we are today if we weren't reusing the supply chain and the ecosystem that has already been built, and the problems that have already been solved. So I don't know, sort of think we're doing things wrong today that we did right before, because we're still doing a lot of those same things. We're just a bunch of new problems that we've got to solve on top of it.
Yep. I reflect back on our time working together to build out that cloud infrastructure. And the pace felt immensely challenging. It pushed us, it pushed our teams every single day to stay on top of. And what we're doing today pales in comparison. And I remember working on taking design cycles for silicon, trying to get them within 5 years of concept through to production. And then I look at, at Cornelis now, a much smaller team, much more focused in a singular area of networking. And our design cycles are 12 to 18 months. And so it's a whole pace change that goes along with it. But I have to agree with what Zane said about the foundations of each prior experience are what gives you the launching pad for the next one, even if the technological problem of a scale out, respond to everything versus a highly parallel computing challenge is different architecturally. There's a lot of foundational in there.
Now, you mentioned that you're working in networking. I think that one of the most interesting things about AI compute is that it really takes the concept of balanced computing and dialed in performance equilibrium between compute, network, and storage to the next level. Why is network becoming so critical at this point? And how do you see the industry working on that together to deliver core capabilities within the network?
Yeah, if I'm being fair, when I was really focused on compute, I really said compute was the center of the system. And now that I spend all my days in networking, I say networking is the center of the system. So that's either a me problem or that's actually really a part of what's happening. But I just think that in the world we're living in, compute advancements have had a tremendous amount of attention and resourcing and dollars and innovation put towards them, and have shown just massive scale improvements, like X factors of improvements in order to keep up with the challenge. But the networking, a lot of it's still running on architectures that were built, they're super proficient, but were designed for totally different problems. And so this parallel computing opens up like a new set of requirements that we haven't fully adapted to. And that's why you see all these systems with, 50% utilization of the compute. And for me, when you step back from that as it's a business challenge,
Right.
It's an ecosystem challenge, but actually it is a fundamental civilization challenge to build, again, on what Zane said, because we simply can't afford, from a power perspective, from an infrastructure perspective, from a supply chain perspective, from a minerals perspective, we can't afford to leave that much capacity underutilized, not helping solve these problems. So the thing that gets me excited every day is working with this ecosystem to actually get after it and solve that and drive that utilization of compute forward. And I see the network as one of the biggest unlockers of that potential.
I think the physics is on the side of the comment that the network's becoming the center of
It's not just me. Okay,
it's
cool.
not just where you are.
It's
Any way you want to slice, like, look at how much power is in the network versus in the compute, right?
Yeah.
I mean, it's I don't know exactly. People throw out like 30%. Yeah, it's a lot. But if you look at the very nature of the transformer model and how you train and how you do inference, you have multiple networking problems you have to solve. You have a scale-up network where you have to get all these GPUs acting like they are one machine, fully coherent. That's very difficult challenge, but it's also different than a scale-out problem. Where we have to still maintain some level of coherence, but in a more relaxed latency domain. And it's like, okay, that's getting it to be a bigger and bigger set of challenges. And then now we realize, now I need to think about the hall and multi-hall networking.
Yep.
And now I'm actually looking at scale across so that I can marshal, global compute resources solving on a problem and make that problem incredibly large. And those connections, I think, a little bit like neural connections, like, in your brain. If your brain is a connectivity problem, and AI is fundamentally a connectivity problem. So if you can do the networking better, you're going to save tons of power. You're going to get more interesting AI possibilities. So it's just a very natural place for the center of gravity of the industry to be right now.
I think so many people don't realize at how small of scale the challenge of scale actually really shows up in AI systems and in networking. And we hear, you hear in news, people putting together 500,000 GPU systems, building to 1 million GPU systems. But the real problems at scale literally start once you put 8 together, and it only gets worse from there. It's shocking how small it starts at and how much opportunity there is to improve, and the complexity of scale up as well. So it's an exciting problem that to be a part of, and one of the things I talk about too, not just my team at Cornelis and all of us, but in this domain and space and area we play in, like, your work matters. You have that significance of, we can really make a difference and impact here by improving the scalability of these AI systems.
I know that you guys understand market segmentation really well. You understand the difference between enterprise and hyperscale intimately. Enter the neocloud and providing new challenges in terms of the ways they operate and the ways they want to engage with tech vendors. How do you look at serving, from your respective perspectives, serving these different deployment models, these different types of customers, and the broad proliferation of AI adoption that's coming in the enterprise as well? And what are the key points that you think about in terms of delivering infrastructure capabilities that address those markets?
I think the neoclouds, and it's an interesting term because what is OpenAI? Is that really a neocloud? Is that a hyperscaler now, or what is that definition anymore? But it's interesting, having been in the industry for as long as we have, that no matter how big the incumbents are, there's always a challenger coming with a slight take, a pivot off of both the business model as well as the underlying infrastructure model. And I think that's what we've seen with the neoclouds. Like, what happens when you are building infrastructure first and foremost and solely for this problem, for this application, not saying, oh, I have this massive book of business and how do I also do this? Right. So there's a focus thing there that is interesting, because you're not trying to bolt a solution on to a bunch of existing infrastructure and then also partially optimize. It's very focused, and we see that a lot. The enterprise is a bit different in that what we're seeing a lot with our customer base is a lot of folks that have HPC applications in their business model. So whether that's oil and gas or automotive and drug discovery, all those types of things, those are the ones that are moving most quickly towards also having AI integrated into how they deliver their business.
That makes sense.
And I think some of it, comes from their history of using compute as a fundamental resource to drive their business. And so they have that mindset built in. And that's been an interesting transformation, as a lot of those companies are choosing to actually drive that portion of their business in an on-prem or colo model because of the power of the data. And
I think from an OCP perspective, it's a community. We have lots of members of the community come together to work out solutions in a lot of different segments, including enterprise, even that surprises people sometimes. At an engineering level, I think what's being deployed in neoclouds and what's being deployed in hyperscale increasingly look very similar. And as we, you saw the call to the letter call to action yesterday. It's like there's a real desire out there to standardize elements of these really large scale liquid cooled, DC voltage distributed, massive systems. I don't think you're going to see lots of those systems in some small enterprise data center, right? So that's like a completely different thing. And it doesn't mean there isn't going to be AI there, because AI is just like a very big thing. It sort of boils down to the frontier model world and other AI applications. And I think there's still a lot of ink to be written on what that tail of applications is, and what role smaller models play, what role as what kind of inference solutions are going to be out there closer to deployment and lower latencies to end users and those kind of things. And I think we'll see a lot more experimentation. I feel like enterprises are moving from a lot of experimentation more into like I'm really getting business value out of it in the next 12 months. So I think we will see that segmentation, I think, come up a little bit more into clarity. But in the short term, you're still going to read about just massive gigawatt data centers, and it could be built by a neocloud, it could be built by Oracle, it could be built by Google, that you may see people deploying their infrastructure in all kinds of different modes. And we're already seeing that, obviously, and I think we'll see more and more of that, because finding the power is the thing, and finding a place where you can deploy and scale up or scale down your capacity. People are going to want lots of options for doing that.
And people, I don't know if they fully realize how much of the hyperscale and neocloud is a shared business model. I mean, the neoclouds are being used to provide excess capacity and capabilities to try out new infrastructure styles. I do think as an industry, we are relying a lot more on standards than ever before. OCP, the Ultra Ethernet Consortium, UAL, things like that coming together. It's like these problems are too big to go at alone. And so bringing people towards standards and much more open source, open methodologies will allow for faster solving and scaling of these problems. So I think that trend will continue.
It's interesting. I was preparing for our interviews this week, and I was thinking about what was OCP Summit like last year versus this year. And, there were seedings of exciting things happening in the industry. I recently had a conversation with you, Lisa, where you said, we're doing this with brute force. We need to do it more elegantly. That line has stuck with me. You mentioned the open letter of needing to move faster. So as we look forward, and there's this, strong imperative to move faster as an industry, to work together, to utilize the things that we've started to actually drive broad proliferation of technology. What do you think we're going to be talking about in 26?
I've called this wrong pretty much every year, so
Okay.
And he's the CTO.
I know, but we're not.
It does feel like every year has a little zeitgeist to it, right?
Yeah,
a lot of those things, like
exactly.
in the open letter, feels like that's kind of in the zeitgeist at this show. I feel like that we're going to decisively pivot from a training-dominated ecosystem conversation to an inference-dominated ecosystem, and I think that's going to create new products, new opportunities, new standards that need to be developed. And we're going to see a lot more conversation about that, because that's going to become the first order problem. You already see people with like workload splitting and some of the cool technical advances where people are really architecting for that already. And I think we're just going to, that's going to move center stage. And then, like I mentioned in my last comment, I think we're really going to see a lot more enterprise use cases and people really making money with AI that's going to go hand in hand with that inference. And that may surface, new problems and opportunities. Hopefully, we're celebrating that building out this extraordinary infrastructure has gotten so much easier because of the collaboration across the different companies that everybody seems so eager to do like that.
Yeah. Well, he gave 2 and he was supposed to give 1, so I kind of stole one of mine, which I think in a year we are going to be talking about the rise of the enterprise. And that's really something I see so many advancements. And I look at, again, just even at Cornelis, like we're not encouraging employees to try out new AI tools. We've defined the workflow of how work gets done, and so that utilization of AI is a part of it. And so, we're a silicon and a system and a solution vendor, but we're an enterprise ourselves. And I see that, and I see the way in the last I'll say 6 months, we've reshaped our workforce expectations and how the actual work gets done. And I think that we can probably move a bit faster because we are smaller, but the enterprise is right, behind us in general. It has to happen, and it will.
I want to add a bonus question in here. You guys have talked about the move from training to inference. How do we look at agentic computing within that context, and where do you think it fits in terms of changing workload dynamics?
Maybe I'm going to say something contrarian, but actually the agentic, I see it as a continuation of this momentum that's already started versus a complete redo where you used to have your entire workflow without AI in it, and then you added it, and then agentic goes on top versus, so I don't think it's as big of a step function change as like no AI to AI built into everything you do. So I see it as additive, and I like we're already seeing, adopters are taking steps there. I so much possibility, but I think it's more of an evolution than a revolution.
I tend to agree, but I think one implication that it's going to have, and I don't know if this is really going to be true or not, but in my gut, I think we've maybe neglected a little bit the front side of the machine, the front network, the CPU, as we've engineered this like incredible high bandwidth, fabric around the backside, the GPU of the machine. We have things like RAG, and we have all kinds of, interaction between that machine and traditional databases, and I think that as the agentic builds out, there's going to need to be more bandwidth on the front end. There's going to be security. It's going to be really challenged, and I think we're going to have to engineer the front end of the machine. And I don't know that it's just like a faster NIC feels to me like an insufficient response to the moment. I think people need to rethink the architecture of the front end of the machine quite a bit. And probably smart people are working on that, but I haven't seen a lot of
discussion
out in the open yet. But I think that it's going to demand more of that. And it's going to be it's going to create interesting opportunities for that side of the equation and that part of the ecosystem, which is some players that maybe haven't been like in that LLM training ecosystem are going to get some opportunities.
Yes, the demand profile is changing. So yeah, it'll be interesting.
So I can't wait to start our interview next year with a summary of these prognostications.
Only if we're right. Only if we were right.
If I scored too bad, I might not be able to.
So one final question for both of you. I'm sure that people online want to engage with you and learn more about what you're doing and how they can get involved in the things that you're doing. How can they engage with you and learn more?
Just ping me on LinkedIn.
Okay. And for me, find us at cornelisnetworks.com or also on LinkedIn, both the company and myself. We welcome the conversation on building the future of AI.
Well, Lisa and Zane, it's been a pleasure. Thank you so much.
All right. Thank you.
Thank you.